Welcome back to another lessons learned video, and today we're going to be talking about antiderivatives, so let's begin. But before I start the video, I just want to quickly raise your attention to the earthquakes happening in Syria. Obviously, it's a great tragedy and a lot of people have been affected, so with that I've posted a donation link in the description below, and any donations and help would be highly appreciated, and it would help a lot of people in need. But back to the video. What is an antiderivative? Well, an antiderivative is just the opposite of a derivative. So we know that for derivatives, right, we go from the y function, to y prime, right? Or again, we'd go from y prime to the second derivative, y double prime. Well, for antiderivatives, it's just the opposite. So if we have y prime, we go to y. And if we had y double prime, we would go to y prime, right? So when solving for antiderivatives, if we had the equation y prime equals 3x squared, right? How would we find the original function? Well, there's a power rule that we use. So obviously we have x squared. So what we're going to do is, for the 2, we're going to add 1, and then we're going to divide that by the product of what we have. So it would be 3x over 3, right? So that would equal y equals 3x3 over 3, which is just y equals x to the 3, right? But whenever we have antiderivatives, when we find the antiderivative, right, we always put a plus c. Now, why is this? Because if we have the equations y equals x3 plus 100 or y equals x to 3 plus 50, right? When we find the derivative of this function, they're both going to get 3x squared, correct? So when we get the derivative of this function right here, we get y equals 3x squared, right? But when we want to go back to the original function, we can't account for that 50 or for that 100. So we put plus c to account for all those variations and account for the change in the original function, right? So that shows that we're adding an additional value to it. So another example, if we have y prime equals x to the 4, how would we go back to the original function? Well, y would equal x, we'd raise the power, so x to the 5, and divide it by the power. So x to the 5 over 5, and then we always have to do the plus c. Right, and obviously there are a bunch of rules when it comes to different functions and whatever. So for example, if we had, right, the function y prime equals e to the x, well, anything when we go for the antiderivative of a e function, it just stays the same. So y equals e to the x plus c. And another way we can see antiderivatives is through integrals. So if we had the integral of x to the 4 dx, just like the equation above, right, we'd have, to find the antiderivative, it would be x to the 5 over 5 plus c, right? Now, let's say we had the derivative y equals sine x and passes through the points 0, 2. How would we solve for this? Well, first, we would solve for the antiderivative. So the antiderivative of sine is negative cosine x, right? Now, how did I get here? Let's say we had y equals negative cosine x. What is the derivative of cosine x? Well, the derivative of cosine x is just negative sine, right? So that would be negative sine. But remember, we have a negative right here, so the negatives cancel out, and the antiderivative of sine x would be negative cosine x, right? And then we always have to put the plus c. Now, since we are given points, we can just insert the y values and the x values. So we have 2 equals negative cos 0 plus c, right? So that means 2 equals negative 1 plus c, and therefore c equals 3. That means the original function of this entire question right here would be y equals negative cosine of x plus 3. And that's how we would solve for the c. We always need to be given a point or a value or an x and y value. So that's just a quick summary of antiderivatives. In the next few videos, I'll go over the basic integration rules, for example, like inverse trig, and also how to solve with antiderivatives using u substitution.